Okay, now we're going to apply boundary loads. I'm going to click on the plus button in Solid Mechanics. This is saying we're using a linear elastic model, so anything we get from this model, it's purely in the elastic region. Initial values are if we have any initial stress or displacement or anything on the model, you can give it to it here. We're just going to assume everything's 0. Free and saying that all these boundaries around this rectangle are free. Well, we're going to change that. We want to right click on Solid Mechanics and let's give it a fixed constraint. So what this does here, I'm going to click this boundary and add it, and it gives it this fixed position. If you wanted to add a force going up and a force going down, it doesn't have any reference to judge like where you're pulling it. The whole piece is just going to move. So you have to, let's say in reality this beam is feeling force down in the Y and up in the Y at this boundary. You would have to fix it somewhere and then give it twice the force here, or however you want to do it. But you have to fix something that needs to be the first constraint you add to it. I'm going to go to Solid Mechanics again, and I'm going to apply a boundary load. The boundary load I'm going to apply to this top surface. I'm going to add. Let's make it a total force. So you can have a force per area per unit length. We're just going to do a total force, and we're going to say in the Y of 200. Alright, let me see here. That should be all the boundaries we need. We're pulling here, it's stationary here. Let's now create our mesh. We're going to right click, build all. It's a pretty big mesh right now. Let's do finer, build, and this will leave plenty for what we're looking at. And then you go to right click, compute, and you can see this is a graph. When the colors you see are the von Mises stresses, which are the combined stress in this material. You can change this by opening this up, surface. Let's say you don't want it to show the von Mises stress. You can go here to the little triangle, Solid Mechanics, stress tensor, no, stress tensor in the Y. Can't grab it. Stress tensor in the Y, and graph. And this is the stress. You can see that this value block here, I click here, it's stress about 3.9, and that'd be pascals, because it says, oh, I'm a strain, wait, I'm sorry, this is solid EY, I've clicked strain. You need to go back up here, Solid Mechanics, stress tensor. Y. Okay, so you can see the stress field in the Y component, and you can click here, you get a stress of 100.9. Here, your stress concentrator is 130. It decreases here in the center. You can see these changes of stress, and they're Newton per meter square, so you're looking at pascals. Something else I wanted to mention was you can come up here and give it a thickness. So your beam or whatever you're looking at has some thickness. This is just assumed it's 1 meter. But of course it's a 3D part, and there's no reason to use a 3D mesh if you're just looking at something as simple as tension. So you can change the thickness of your piece so that your stress and strain and everything reflects that. Also, what I want to do is I want to go to geometry. I want to add a point. I'm just going to say here for now. Let's click the point. I want it at 1, halfway in between, and then I'm going to put it at Y is 5. So it's right at the middle of my part. This is going to come in handy in the next section I'm about to do with the results. We're going to plot stress, strain, and deformation and everything like that, and we can look at this at that point. You can also make lines. Come down here. You can also make what's called a cut line. And the first point here, second point here, and we'll look at the changes in stress across that line also. And that'll be for the next section.